Yeah, good afternoon. How are you doing? I'm very sorry the tutorial is coming quite late. And this tutorial will be covering data filtering and cleaning on what we were supposed to do from the last class. So I'll be covering quite a number of things. So as you can see, I'm on my Jupyter notebook. This is my browser and you can see my markdown up there. So we're starting with data filtering. And my first, what you can see is actually importing my needed libraries. So for this tutorial, we'll be needing the Pandas library and the NumPy library. So I run that ahead of time. So the second cell you can see here is I already have a data set on my system, and the data set is about the just concluded US election, uh, containing the votes, the party, and the various counties. And in our local area, the concept of county is just like political parties in more like sections. And I checked Wikipedia for the meaning of county. It's subdivision, political subdivision of a state. So in a state, you may have certain number of political subdivision, just like we have wards. Yeah, just like we have wards in this part of the country. So I'll import my data. I know we are familiar with that too. I have the first 10 data point here. I have the first 10 rows. And we can see the details, the states, the counties, the candidates. You can see Donald Trump, you can see Joe Biden, the party they from, and the total votes they were able to capture, and who actually won. So we have it like that, and we can check the size of our data set to be much more. So I can check the chip, so I can run that. So we have 32,147 rows. And what that means is the rows is like they're having about 32,147 watts kind of in the whole country. So just for me to see the state, the major state there, I just want to see the state. So I selected. So from what we are doing, I'm interested in only the state. I just want to see only the state. And if we can follow up here, we can see that there are repetition of states, because in a state you can have like many political subdivisions. So, but I actually am interested in just the states. So I ran that here. So I have df the state. If I run df, if I run df state only, you will see we have duplicates. We have duplicate. So to be able to do that, so I did what I call unique. So that will give me the unique values in the state row. So if I run this, you can see the state. So I need the unique values in this particular column. So I used that to get that. As you can see, these are the states here, quite number of them: Alabama, Mississippi, New Jersey, Texas, Florida, and so on. So let's see how can we filter down by specifics and conditions. How can we filter down just by specifics? So here we're able to just filter down by just, okay, I don't need a particular column. But here, what if in that particular column, I'm only interested in some specifics in that particular column. So as you can see here, okay, maybe I'm only interested um in those data that came from Texas. Yeah. So I can actually filter that down with this condition. Here is what you can see, which can see my condition. You can see my condition there. So my condition is I'm interested in the state that are from Texas. So let me run this and let's see what we have. So you can see our output is in form of a boolean. We have a false true, true false, and that's a concern, right? But there's a way to go about it. So we need our response in form of a data frame, not in form of a boolean. So to be able to capture that, so what you will do is you save your condition in a particular variable. In my case, I called it field Texas. So then I'll come down here and I'll put in my condition and I will do df.look. And what that means is to go and locate for me those those data points that are actually true with the conditions that you subjected it to. And when I run that, as you can see, we really have state from Texas. So we can see all the votes from Texas here. So there are about over 1,000 rows. So the votes from Texas. So what if I'm only interested in not just vote from Texas, but also vote, maybe I'm an analyst for President Donald Trump, and maybe I'm only interested in his vote from that particular county, or that particular state rather. So I can add more than a condition together. And as you can see, it's a good practice that you put your condition, you put it in a parenthesis. So as you can see, I have a condition here, checking if in the column candidates, if the name is Donald Trump and also the state is Texas. So when I run this, so just as you can see, but if you take note here, I've already put in the DF look I was talking about here. So I have my condition here, then I put it inside the DF look. So as you can see, I only have votes from Texas that belongs to President Donald Trump, and you can see the vote there. So there are some states he won, there are some counties he won, and there are some that he lost. So possibly maybe I'm interested, maybe I want to find the percentage, the impact of his vote, the vote from Texas on his total vote. So what I can actually do is, okay, let me just do the sum. So as you can see, I've created a new data frame here called Texas. So, and maybe I'm interested in, and now in this case, I'm interested in the total vote, and I want to sum up all the total votes. As you can see, that was what I did here in this cell. So I found the sum of all the votes coming from Texas that are for Donald Trump. So and then also now there's an other instruction below this which I ran. Now if you want to get the percentage, it has to be the specific over the total population times 100. So what I want to also need also, okay, I'm trying to look for the impact of his vote from Texas on his total vote. So that means on the general, I need to get the total vote captured by Donald Trump in total. So now it is the Texas vote is actually Texas is now is a data frame different now, but DF, according to what we have here, DF still remains the actual the whole set, the whole population from that particular data set. So you can see my condition here. So okay, if the candidate is Donald Trump, then I ask you to go and pick the column of total vote and come and get me the sum. So if you can break this down, I intentionally make this way. These they are together. So you have it in form of a data frame. Yes, that's what you have it to be. Then the total vote in that particular column, after this condition has been met, then take the sum for me. So when I run that, and in this cell, I actually did the percentage and the calculation of the thing. So when I run this, so I can see that Texas had about 7.9% of Donald Trump total vote. Yes, he had 7.9% of his vote from there. So we can actually do quite a long number of things. Maybe for instance, I want to get the number of wins, the number of counties that Donald Trump actually won, the number of counties he actually won in the whole total data frame. So, and that's what you can see here, DF candidate with Donald Trump. Then, okay, I have this new data set called Donald. then do the value count. So count it, okay, which of them did it actually win, so they actually. So when I run that, so true, that means in one 3,219 and it lost 1,149. So if we go back and we look at the size of our counties, where do I have that? So let me just quickly do the DF info there to load the total number of counties I have. So DF info. So okay, I have how many? Okay, I have uh, uh, okay, come in. Okay, 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 okay. Um, Let me go down to check what I actually have here. Okay, so the one he actually um in the one column. So for Donald Trump, he has 3,219 counts, and yes, he has, yes. Okay, okay. Why not? Then let me do it that way. Um, um, okay, okay. Let me do it this way. Um, Let me join the two conditions together. Let me join the two conditions together. So I'll put it this way. Um, if the candidate is Donald Trump and he actually won. So let's take a look. Okay, 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 okay. Yeah, that's it. Yes, that's the way to go about it. Yes. So I have it to be that. So let's move forward to data cleaning. So I haven't checked this US election. I realized that there's no way you can get missing data because it's a very, very sensitive subject. So there's no county that maybe possibly there's no vote or something went wrong. So the data is so complete. The data is so complete. So I went ahead to look for another data set which we'll be familiar with in the class. So this is actually power data. It's about energy that was captured from some particular houses. So let's see what it looks like. So this is what it looks like. We have the meter ID, we have their tariff, we have the daytime, we have the energy, and we have the group they belong to. So now I'm not too cool with the columns, so I decided to change that with the line we can see from here. So I use the variable name new DF against what we're familiar with because we already use DF the former data set. So I changed the column here to something familiar. Then also, if I do something, if I let's just take a look at something. It's a serious challenge that made your data scientist while you are cleaning your data, you can be bound to face. So if you check, you can see they are objects and um, why will energy be an object? That means if I want to calculate or do any manipulation, it's going to be quite tedious for me. So what I did here was that I decided to convert most especially this energy value to um, to a format that at least can be computed. So what I did after changing the column was to strip off every empty space in that column, strip off any empty space in this column. So after that, I decided to convert it to a numeric form that we can actually calculate. So when I run this, so we have it that way. So let's now see what data looks like. So as you can see, it's now in a computable format 0.00 something. So it has converted this to a format that can be computed. And if we do, if we check the data, the, the the format now, so you can see energy is now a float data type. So to just touch few things before we wrap it up, just like we're looking at filtering, you can see, okay, what if maybe let me see, I want to see those data, those energy that actually have values to be zero. So as you can see, here is my condition. So if the energy column is equals to zero, so here's my condition. So I try to pass this my condition into my new df.log. So and if you want to see that, let me just show that to us. So and I run this, so you can see about 46,000 rows as the energy value to be zero. That's much. And if we check the size of our by data frame is about, it's 1 million data set. So about 46,000 actually have the energy value to check. So what can we do? In because of cleaning this, we can do many things. We can decide to maybe replace any value that is zero with the NaN value, which is like not a value, yeah, not a value that can be computed, so that we can do some other things with it. And maybe we can decide to actually drop that particular, but the first one I want us to do first is to replace to replace any value like zero with an NaN. So we do that with this command. You can see my data frame dot replace. Then what do I want to replace? Any value that is zero, replace it with NaN. So when I run this, so let's see how my, so you can see this is how my data frame looks now. So I still have it, but if you are zero, you become NaN. And let me now check here if I have any value to be zero. Now what I didn't perfect is to put in place to be true here. So we know what that does. So by doing that, and if I do new energy, if you check if it's zero any longer, you can see none of the value is zero. Maybe if I want to actually see properly, let me do new df. Let me just check. So there is none that is now zero because I've replaced them with NaN. Then maybe if I want to check if it's np.NaN, you can see okay, yeah. So that is that. Then maybe we actually want to maybe we want to we want to drop, NaN, like we want to remove them from, like, just take them off the street, take them off anything. If you are NaN, just get off. So let me check and see what our data frame looks like now. Okay, we still have this. So now if I do drop NaN, it's going to remove any rows that has NaN in it. So when I do that and see what it's like, so you can see that's taken away. See, there's 3, 4, they are gone. They are gone. They are gone. Any rows has to be zero. So if I want to make this, let me check. Let me see how my drop any. Let me see how my DF, my new DF is now. Maybe I'll need to do in place to be true. So I need to do in place to be true. So I'll permanent that by saying in place to be true. So when I do that, when I run my DF now, as you can see it's gone, and it's gone finally. So that's how far we can go in this tutorial. So in our class tonight, we'll be dwelling more on how much more we can use drop NA to clean our data set further. So till next time with us, so see us in the evening. Thank you so much.